Hello students, welcome back. We completed problem 1. Actually, no, we didn't complete it. I completed giving you hints on problem 1. And then in the previous video, I went through problem 2 using method 1, critical value method. Now, the reason I emphasize critical value method more than anything is because of my experience. I used to explain all these in equal weight, and year after year, semester after semester, students who did critical value method performed the best, and the student who used probability value method did the worst, and the student who used hybrid method somewhere in between. That was my result year after year after year for 5 or 6 years straight. So now I adjusted. For past several years, I've been emphasizing critical value method the most. Our textbook author, on the other hand, emphasizes probability value method. So I have to do both. And in the previous video, I did it using critical value method. In this video, I'm doing probability value method. So if you like your textbook's way, this is the way to go. Okay, let's begin. Let's start from the scratch. The article, a trial of lopinavir-ritonavir in adults hospitalized in severe COVID-19, New England Journal of Medicine, published in May 7, 2020 by Kao et al., reports the following study on possible SARS-CoV-2 virus treatment with lopinavir-ritonavir, originally a HIV medicine. A total of 199 patients with laboratory-confirmed SARS-CoV-2 infection underwent randomization. 99 were assigned to the treatment group and 100 to the standard care group, the control group. The article summarizes its main result as follows. Mortality at 28 days was similar to the treatment group and the control group, 19.2% versus 25.0%. The difference was negative 5.8% points. So the difference was similar, which means no statistically significant improvement, which means this HIV medicine is not really working very well. That was the conclusion. So if you set up hypothesis and test it, it's likely that the null hypothesis will win. No difference. But let's forget about all that, and let's pretend you're working the mathematical part for this research group, okay? So let's pretend you don't know the conclusion, and let's just work with these numbers. Okay, all right, let's set up the hypothesis. We are doing two-sample inference, okay? So always the hypothesis is no difference, unless the problem explicitly states the difference is blah, blah, blah. Nothing like that, then set it equal to 0. Default is 0. So, no difference. No statistically significant difference. Now, how about the alternative hypothesis? I was a little bit premature showing you this. Pretend you didn't see it. Do I take less than 0 or greater than 0? Use two criteria. Number one, alternative hypothesis, of course, is this medicine working. So do you want lower mortality rate or higher mortality rate? Mortality rate must go down, and that's why we are taking negative. That's criterion number one. That comes from context. Now let's go to the criterion number 2. This sample study gave you negative 5.8 percentage point or negative 0.058. That's negative, so we have to have negative. Use both criteria. Okay, so we have the hypothesis set up. And by the way, if you use just plain equality and plain less than, that's fine. I'm not going to take off any point. The reason I use this regular equality because nothing is ever precise in statistics. And here I'm using not just less than, but statistically significantly less. That's because I'm a teacher. I have to be perfect in all those notation. If you use just plain notation, it's going to be okay. But there's no question this is better. Statistically, no significant difference. Statistically, significantly less. Okay, all right. We're done with the hypothesis, and let's go to the next step. Let's draw a picture. Oh, excuse me. Before that, we have to do standard error computation, but no problem there. We already did it in problem number 1. So we have SC1 squared plus SC2 squared. And SC formulae themselves had those square root in there. So by removing the square roots, I'm taking the squares and then calculate all these. We have this result, 0.058 something, about the same as this difference. So the experienced student will see null would win already, because you see in natural science like physics or astronomy or things like those, you want something like 5 standard deviation difference, which is extremely unlikely in just plain coincidence. In life sciences, still you want something like 3 standard deviations away. But 1 standard deviation away is really small difference. You can already see that. Okay, let's go to the picture. Outline, center, end, and shade. That's a process. Outline doesn't really have to be really pretty. And then center. Center is the null hypothesis here. 0. No difference here. Now, where do you put end? We are doing probability value method, right? All right. Okay, we want to get p-value. So we use the given difference here with negative 5.8 percentage points. Negative 0.058 is given, it go over there. And then shade. This part we shaded in purple here. And we want to find out this probability value. So far so good, but conclusion is a little bit confusing. What do you mean by big P? What do you mean by small p? And that can get a little bit confusing, because this p-value, as a matter of fact, is a conditional probability. A conditional probability, given that null is right, probability of this observed mean is less than this threshold, but just by coincidence. Oh, did I make sense? I don't blame you if you didn't understand, because this is hard concept, and that's why students who went through this probability method often fails, because it's hard to understand. What do you mean by big P? What do you mean by small p? Which is which? That's where a lot of students get confused. So I'm giving you a bit of a cheating method. I don't really encourage it, but here we go. It works most of the time. Roughly speaking, this p-value is roughly speaking is the probability that the null is right. Don't tell this to any mathematician, because this is plain wrong. But if you take this cheating step, then you can do the problem a little more easily. Okay, I'll just leave it at that. So this statement is incorrect, as a matter of fact, but it'll help you anyway. So p-value is roughly speaking, p-value is the probability that null is right. So big P, then null is right. Small p, null is wrong. Okay, all right? Okay, and then let's calculate the probability value. Z-score is n minus center over SC, a formula so important that I tell my students formula number 1 of the entire course. And that is approximately equal to what? What's the end? Negative 0.058 something. And center, oh, that's 0, that's easy. And standard error, that's something you calculated in problem 1a. So you have all these things calculated, and you're going to get your z-score. Get the z-score, assuming you did it right. You can get your probability through the z-table here. So this proportion, same as the left-hand side, that proportion. So you don't have to take 1 minus, all right? And then get your z-score that you calculated somewhere. And then it's likely to be negative 0 point something or something really large here. And then you're going to get appropriate probability there. That's your p-value. Is p-value greater than alpha or less than alpha is a problem? Where is the problem? Yeah. Greater than alpha or less than alpha is a problem. And then that's where students make a lot of mistake. Greater than alpha, but what does that mean? And then get confused and guess wrong. But if you take, what extra step, or where is it? Oh, I guess I erased it. Okay, if you take that extra step, the p-value is, roughly speaking, the probability null is right. And then that'll help you. Big P, bigger than alpha, null is correct. Small p, less than alpha, null is wrong. If you actually do your computation, it'll turn out like this. P is big, 1.61 something, about 16% or something like that. So certainly greater than 5%. Big P, roughly speaking, that's the probability that null is right. So null is right. We accept the null hypothesis. Reject alternative and accept null, or fail to reject null, whatever term you want to use, I'll accept it. As for detailed computation, you have to do on your own, and that completes the probability value method. Okay, all right. 2 more methods are here, and I'll talk about those in separate videos, even though I don't see many students who would be going that way, but I'll talk about it anyway. Stop.